In this video, we want to start our review for our final exam, and this is our first review worksheet. So I'm going to go over the worksheet here, and then there's a homework that goes along with this. Our first problem, find g of f of 2. And if you remember, this means g of f of 2. So we take the 2, we plug that into f, and we get 7. So this is g of 7. And we plug 7 into g, and we get 50. F of g of x is f of g of x. So we put the whole function in. So this is f of x squared plus 1. And now we put that whole x squared plus 1 into f. So this gives us 3x squared plus 1 plus 1. And if we FOIL that, distribute that out, we get 3x squared plus 4. Put a box around our two answers. All right, number 2, find the inverse. If you remember to find the inverse, first we have to check if it's 1-to-1, and this is, so we're okay there. Our first step is to switch our x's and our y's. So I switch my x's and our y's. And then after I've switched the x's and the y's, I want to solve for y. So I'm going to multiply by 2 to get to 2x. I'm going to add 3. So that is 2x plus 3. And finally, to find y, or our inverse function, whatever notation you want to use here, we are going to divide by 7, so that is 2x plus 3 over 7. Some more problems here using inverses. Remember, as we just said, inverses kind of switch our x's and our y's. So if my original function, when you plug in x, your y, you plug in 4, your y is 2. If you plug in 2, your y is 5. Now, if you remember, when we do inverses, the x's and y's switch. So for my inverse function, if I plug a y of 2 in, I should get the x. Well, from up here, you can see here is my y of 2, so my x should be 4. And my f of 2, now this is the regular function, so this is just my x. I want to find my y, which is just 4. Next, we want to look at solving some log and exponential equations. And if you remember, many times if you have a logarithmic equation, the first thing you want to do is write it in exponential form. So if I take log base 2 of x is 4, and I write it in this exponential form, this would be 2 to the 4th equals x. So that means x is just equal to 16. If I have log base x of 3 equals 27, this is x to the 27 equals 3. So to do that, I'm going to take the 27th root of both sides. Or if you remember, the 27th root, I could rewrite that as 3 to the 1 over 27th power. And that is absolutely going to be a calculator thing. So if we do, we'll do it both ways here. If we do the 27th root of 3, or if we do 3 to the 127th, you can see we get the same answer either way, 1.042. If we have an exponential equation, we're going to write it in logarithmic form. So 2 to the x is 24 would be log of 2, base 2, of 24. And if you remember how we can do that in our calculator, we can go to our math, we can go down to our log base, and we put 2, 24, enter, and we get 4.585. If we have 7 equals 4e to the 2x, the first thing we need to do is we need to divide by 4. So in order to write an exponential into logarithmic form, you have to have just the exponential on one side. Now, it's e, so that's going to be natural log. So this gives me natural log of 7/4 equals 2x. So if I want to solve for x, this would be just natural log of 7/4 divided by 2. And we could leave it like that, or we could throw that into a calculator to simplify. Next, if we're given a graph, we want to graph f of x plus 1 minus 2. Remember, this on the outside moves it up or down. So this is going to be down 2. The inside moves it left or right. Since it's a plus, that means it goes left 1. So I'm going to take this graph and go left 1, down 2. So we're going to take this point right here, go left 1, down 1, 2. It gets to right there. This point right here, we're going to go left 1, down 2. That goes to right there. So if we finish our graph, we get to there. Finding integral, the indicated term of sequence. There's a whole lot of formulas for sequences and series that we want to have available to use as we're doing this. If we're finding the indicated term here for an arithmetic sequence, our formula is a sub n, a sub 1 plus n minus 1 times d. So my sixth term is my first term plus 6 minus 1. If it's arithmetic, I have to figure out what do I add to get the next term, and in this case it is 8. So if I put that in my formula, I get 44. If it's geometric, my formula is a sub 1 times r to the n minus 1. So my first term is 4, and we're finding our sixth term, 6 minus 1. And for geometric, you want to figure out what do you multiply by to get your next term. And this is 3. So 4 times 3 to the 5th is 972. If we look at solving the equality, and more specifically, the big part here, we're going to talk about what is interval notation. So if I solve this, I get 4x minus 8, 12 minus 6x. And if I move everything around, I'm going to get 20. Remember, anytime you add or subtract a negative, or multiply or divide a negative, you need to flip your sign. So we're left with x is greater than 2. So in interval notation, that's going to be 2 to infinity. Remember, always a parenthesis on infinity. And if it's a greater than or less than, it's a parenthesis. And if you have an equals to, as we do here, that is a bracket. Next, we have sequence that's recursive. So remember, this t n minus 1 just is a fancy thing for saying the last term. So t sub 1 is 4. T sub 2 is 2 times the last term minus 3. So that's our last term. And that's 8 minus 3 is 5. My third term is 2 times the last term minus 3. My last term is 5. So that's 7. And now to find my fourth term, 2, my last term minus 3, minus 3, 7 drops into there, and that is 11. So my fourth term is 11. If we have a series with sigma notation, remember the bottom number is the start, the top number is where you end. And we could, if we were just wanted to know, evaluate this and what's it equal, sum up all the terms. That we can do in the calculator. But if we want to know what is the third term, we have to write it out. So we start at the bottom. If I put 2 in, I have 2 times 2 plus 1, that's 5. If I put 3 in, 2 times 3 plus 1 is 7. Put 4 in, 2 times 4 plus 1 is 9. Then I put 5 in, 2 times 5 plus 1 is 11. So there are my terms. So if I'm looking for what is the third term is 9. Remember just some terminology here. This is what's called expand the series. And then if I add these up, 9 plus 11 is 20 and 12. This is 32. This right here is called evaluate. So there's a different kind of things we can do with sigma notation. Conic sections. Remember our conic sections. We have ellipses, parabolas, hyperbolas, and circles. Once again, a lot of different formulas here. Right here, we just want to look at finding the center. From the x, we take the opposite, we just get 2. From the y, we take the same one, and we get 0. Remember, a hyperbola is just like this, but it has a minus sign. A parabola doesn't have one of the variables squared. All right, given the polynomial, is x minus 1 a factor? To do that, I'm going to do synthetic division. If it's x minus 1, that means I put 1 in the box, and that's 1, 5, 2, 8. And we do synthetic division. I drop the 1, I multiply, I add, I multiply, I add, I multiply, and I get a 0. So is this a factor? Yes, because my remainder is 0. So if negative 2 is a root, find all the roots. So if negative 2 is a root also, let's do synthetic division with negative 2 also. 1 is negative 2, is 3, is negative 6, is negative 4, is 8, is 0. So if I'm looking for my roots, actually from number 1, I knew that negative 1, or excuse me, I knew that 1 was a root. So I know that 1 is a root. I know that negative 2 is a root. Now I need to find the other one by the fundamental theorem of algebra. This is a cubic, so I need 3. So down here, this would be x squared plus 3x minus 4, which if I factor that, I will get x plus 4, x minus 1. And here you can see here is that factor that I got from the first one to show that yes, it is a factor. So if my factor is x plus 4, my other root is negative 4. So that is all the problems from the review for the final exam, number 1.